Hi, my name is Andy Roberts. I'm the creator of Live Parts. In this video, I'm going to talk a little bit about how to set up forces in Live Parts to get the best results. This is release 1.7 of Live Parts, and we are in the process now of adding functionality for future releases of Live Parts where you'll be able to specify the actual loads and boundary conditions and material properties, and the system will use a very accurate finite element analysis solver to generate the live parts according to those material properties and loads. Today in Live Parts we use a generic material, and therefore you need to set your forces to be about 1/10 what they normally would be. So in this case we've decided to set up forces for this GE jet mount part to mimic essentially what's going on in the real world part. In this case there's a combination of both static and dynamic forces defined on this part. I'm going to show you one of the forces on this upper surface here. This is a cylindrical surface, and it has a force that moves in the z direction, which is a horizontal plane away from us and towards us. If I go ahead and edit this feature, what we're going to see in the user interface is that we've picked the surface here in the surfaces section, which corresponds to that inside cylinder. And then we've done two things. We've specified for this force, which is a linear force using the XYZ direction, we've specified the elements of the direction as well as the element of magnitude. Now in the real part, this part I believe had about 17,000 newtons of force oscillating back and forth in the Z direction as a torque around the upper portion of this bracket. So what we did is we divided these forces by a factor of 10 to scale them down into the region where the generic Live Parts material operates. What's important to know that is we're scaling these forces down because the Live Parts elastic region is about 1/10 what it is for something like titanium, or in some cases even more elastic. Start out by dividing your forces by 10, and if you need to double or triple that, you can. So here we've given the force a magnitude of 1700 newtons, and for the direction of the force I've used an expression here. You can use expressions in Live Parts to make the values of your magnitude and direction components be dynamic. So in this case I've specified the z direction to be -1 times the sine of 0.2 times t. What that's doing is it's causing the magnitude of the z component to switch back and forth from a -1 to a +1, and because this is a vector, it will be normalized. So what we'll end up with is basically an impulse where the force is going to shoot back and forth between -1 and 1 using the period of 0.2 times t. So that's how you can set up your forces to be dynamic. In this case we've also defined multiple forces, so we have a combination of forces on these two cylindrical surfaces, and some of them are dynamic and some of them are static. And what we see when we go over to Live Parts is that this part will grow essentially to support these dynamic forces. So you can see here that we have the impulse that's shooting back and forth on the right side, and we also have these static forces defined on the other surfaces. And this is the live part that grew as a result of this. This part is normally manufactured out of titanium, and these forces are fairly large, like 4,000 to 5,000 pounds on each of these brackets. When I go ahead and smooth this, we'll get a look at this. You can see that it's essentially fully grown. At this point I could export it and bring it into SOLIDWORKS as a fully solid part. So that's a summary of how to set up forces and how to map the real forces into Live Parts forces, and how to manipulate the values of both the magnitude and the direction using a combination of expressions and constant values. Thank you.